Okay, we are going to start explaining superposition in AC circuit. We explained previously how to use superposition with DC circuits. And today we are going to include also AC circuits. Just let me remind you by the superposition theorem. It's a powerful tool in electrical engineering that simplifies the analysis of complex circuits. How? By breaking them down into simpler, more manageable components. Its primary advantage lies in its ability to independently analyze the effects of individual voltage or current source within a circuit, making troubleshooting and design optimization significantly easier. So usually if we have any circuit or network, and you might have many sources, like maybe you have current source, DC, or maybe you have current source, AC, or maybe you have voltage source, DC, or also you can have like another source, AC, can have many. So when you have circuit like that, many sources, so superposition will simplify the circuit by isolating each source within a circuit and analyzing its effect independently. So for example, you have source E1, you have E2, you have I1, I2, 4 sources. So every time you are going to apply only one source, and then the other source will set them to 0. For example, in this network, you want to have E1 first. So you will have the same circuit here as it is, don't change it. And you're going to apply the first one, E1. So E2 will be 0, so it will be like a short circuit. I1 will be open circuit, because current source, you put 0, I equals 0, it means open circuit. The same thing, so just you will have the circuit only have one source, E1. And the same thing, when you want to apply E2, you will have E2, and then E1 will be short circuit. This is an open circuit. If you want to apply, for example, I1, let me just give an example for current source. You will have a current source applied, which say I1, and this is the I1 will be applied, and I2 is 0, and the other sources will be short circuit because they are voltage source, and only apply I1. So every time you apply only one source, so that's how we say that it simplifies the circuit by isolating each source within a circuit and analyzing its effect independently. The superposition theorem simplifies the overall analysis process. Okay, and also it's efficient. Why it's efficient? Because instead of solving for multiple variables simultaneously, the superposition theorem allows engineers to solve for one variable at a time. So this approach often reduces the computational complexity of circuit analysis, saving time and resources. Flexible also. Why? Because superposition theorem is applicable to both linear and nonlinear circuits, providing engineers with a versatile tool for analyzing a wide range of circuit configurations and components. Okay, let me show you a simple example for superposition, which really other methods will not be easy to do it. Like what? Let's say that you have a circuit here. You have an inductor, has 1.5 H inductance. Resistor has 5 ohm resistance. And let's have another resistance, 10 ohm, capacitor at 10 millifarad, and you have two sources. One is DC, and the value of this voltage is equal to 30 volts, and that's the reference. The other source is AC, and it's E1, and it's equal to let's say 10 root 2 sine 10t. Okay, let's just make it clear, that's t, 10t voltage. And it's required to find the current I of t in the inductor 1.5H. So if this problem is given and you want to solve it, you will not be able to solve it using like node or mesh or thing. Why? For simple reason. You have two different sources. This one is AC, has frequency of omega equal 10 radian per second. Let me just write that. That's the first thing I understand that. So the omega 1 here is equal to 10 radian per second. And the other source is ZC. The frequency is 0. So how can you deal with two different sources with two different frequencies? That's frequency 0 because DC, that's frequency 10, and you have elements like L and C that they are affected by the frequency. Will have different values when you are using different frequencies. So it looks to me like the only way I can solve it using superposition. According to superposition, I'm going to apply only one source, if you remember. We did that in the beginning of the semester. So let's just apply first E1, and E2 will be 0, means will be a wire short circuit. So I'm going just to make a copy of the circuit, and I'm going to show you the change. So make a copy here, and I'm going to apply E1 only. So I'll say E1 is applied, while E2 will be equal to 0. That's the first thing we're going to do. Well, when you do that, I will remove the voltage source and I will make short circuit. Okay. And I will start to solve this circuit due to E1. Well, all right. Remember that you got to use a root mean square. So I'll say E1 is equal to, let's say 10 root 2. So you divide by root 2 to get the root mean square. So you have 10 only. All right. And sine 10t, the angle is 0. There's no shift voltage. I expressed by root mean square. Remember that. Let me just write how you find the root mean square is equal V maximum divided by root 2. That's what I did. I just divided by root 2. When I divide by root 2, this is gone. I got 10. And angle 0. That's AC, obviously, and sinusoidal too. Now, second step, I'm going to calculate the value for XL and XC. Remember that omega for this source is equal 10. I found it's equal 10. Sine 10t. All right. So 10 radian per second. Now we start to find XL. XL is equal omega L. Omega is equal 10, and L is equal 1.5 Henry. That would be equal 15 ohm. So accordingly, we can say that the impedance of the inductor is equal J15. XC is equal 1 over omega C. 1 of omega is equal 10, and C is equal 10 millihenry. So 10 times 10 negative 3 will be equal 1 over, that's 100, 10 negative 3 will be 10 negative 1, means equal 10 ohm. Accordingly, I can find ZL is equal minus J10. So I already found the values. So I'm going to replace it. That's XL, and that's, and that's ZL. J15, that's for the inductor, and for the capacitor, minus J10 ohm, of course. I'm going to solve this circuit. That's very simple. First, observe that the resistance 10 ohm is in parallel, connected in parallel with this one, because they are connected to the same two nodes. This node and this node, the ground. See, this node, if we call this, for example, node, let's say call it node 1, and this is node 0. So between node 1 and 0, you have a capacitor between 1 and 0, 10. So both they are connected to the same two nodes, so you are in parallel, have the same voltage. So you find the equivalent of these two for these two impedance. They are parallel, so how we will do that? So we'll say, let's call it Z1, for example. So it says G1 is equal, so when you review, you know what I'm doing. I'm just trying to find the equivalent of this one, call it G1. 10 is in parallel with minus J10. So how you find this when they are in parallel? You multiply the product over the sum. So you have 10, and I multiply, and then I divide it. I can do that in the calculator. And I will find is equal to 5 minus J5. Don't convert it to polar, just leave it like that. So I represent it as a box, and I write Z1 equal 5 minus J5. What is the other impedance? I will call it Z2. And that is the source. Z1. That's Z1. Z1, it's 5 ohm and J15, they are connected in series, so I write 5 plus J15. Look at it again, 5 and J15. Okay. So what is Z total? Z total, they are in series, Z1 and Z2, they are, that's 2, I'm sorry, that's 2. So Z total, the total impedance is equal to Z1 plus Z2. Z1 is equal 5 minus J5, and Z2 is equal 5 plus J15. Add these two impedances, so I can get the total. It's equal 10 plus J10 ohm. Okay, so that's the total impedance. Great. So I want to find the current. Remember that you want to find the current IT. But this one, I'm going to call it I1T. Why? Because I'm calculating not the total current. I'm calculating the current due to E1. So let's just write the I1 of T as the current through the inductor due to E1 only. So how you find it? Of course, I'm going to do it as a phasor. I will be how you find the current here. The current, you divide the voltage by the total impedance, you get the current, because the total current is the same current flowing in the impedance, because they are connected in series. So it will be equal to E1, the voltage, divided by the total impedance. It should be like phasor. E1, we know that E1 is equal to 10 on angle 0. That was given, root mean square, divided by the total impedance, which is 10 plus J10. It's okay to leave it like that. And then you find the current. You find the answer will be points. Let me just tell you how I got on the calculator the value. I got it in a Cartesian form, which was 0.5 minus J 0.5 m, and then I converted to polar, because as I said previously, it's better to express the current in polar form, and you have to in this one. I'm going to tell you why. 0.707 on angle negative 45 degree m. You should convert this to time domain. That's phasor. So how you convert time domain? Remember, this is root mean square. To find the instantaneous current I1, what does it mean instantaneous? Like we write small letter like that. How you express that? Should be sinusoidal wave. First, you have to get the maximum value. How we find the maximum value? The maximum value for I1, you get it by multiplying the root mean square by square root of 2. So you have 0.707 times square root of 2. You get 1. So the magnitude is 1 amp. That's the phase difference, negative 45. So how we write the expression? Say I1 as a function of time equal the maximum current, which is 1. That's the amplitude. Sine omega t. Omega is equal 10 t plus the shift. The shift is equal 45 degree. You write it like that. And so that's the first component of the current due to E1. If you just like to sketch it, just something fast, okay, I will say if you do sine wave, okay, not bad. Let me do another half cycle. So the maximum is 1, the minimum is -1. But shifted -45 degree, it means it starts late. So if you extend this axis, this should be the angle 45 degree. And just to make, if this is 90, so 45 be like half square. So let's say that the axis will be starting from here. So that's the 0, and this is the 45. And you can extend, you know, if you make like that. See how you make it. Okay, so it looks like that. So this represents 1 sine 10t minus 45. You start from the starting of sine 45. Okay, that's how you sketch it. Well, now we want to find the current due to the DC. So you're going to get the circuit exactly similar to the DC when we did last time. But this is important because it has now two different sources. One AC, one DC. All right. So now I'm going to apply E2. All right. And I will put E1 equal to 0. So it means I'm going to remove this. And I will just put short circuit. And if you observe, I kept the current direction IT in this direction. However, I know that the current will flow in this direction, but I have to keep the current in this direction. If you want to use this direction, remember in the end, after you solve, that will be opposite to the current. But also to make sure that's not I, it's I2. Why? Because I'm using only E2. I'm using only the source. So the current due, the component which is corresponding to E2 is I2. And it should be in this direction. If you want to call anything else, you can. All right. For example, if this is I2 in this direction, if you want to make the current going in this direction, you'll make it minus I2. All right. Just I'm trying to know, but I'm going to avoid. Now I'm asking something now very interesting. So if you have DC and you are solving the circuit, of course, at steady state. So do you remember from the course you had last semester? What does L behave in DC? What does the capacitor behave in DC? In DC, the inductor behave as short circuit. The capacitor behave like open circuit. So what do you mean by that? It means I'm going to remove this inductor and then put short circuit. And I'm going to remove the capacitor. Nothing. I bought nothing. It's open circuit. So now that's your circuit when you have DC. Excellent. Well, so what you're going to do now? Well, what we're going to do, I try to find the current. All right. It's a very simple circuit here, actually. So if I keep the current in this direction, let me just keep the current as I put it here. According to Ohm's law, that will be the positive, that's the negative, that's the positive, that's the negative, right? So now let's just apply Kirchhoff voltage law, and I'm moving in this direction. So let's take the first polarity that I face. So I'll write Kirchhoff voltage law. So you have positive 5 ohm times I2, and then you have positive 10 ohm times the current. It's the same current I2 also, and positive plus E2, which is equal to 30 DC, that will be equal to 0. 5I2 plus 10I2, that's equal 15I2 plus 30 is equal to 0. So 15I2 is equal to negative 30. So I2 is equal negative 30 divided by 15 equal minus 2 amp. So I got the current is equal minus 2 amp, and I kept the same direction here by applying Kirchhoff voltage law. So I got the two components. How you sketch this one? Oh, that's easy. It's DC and it's equal negative 2. So you comment at negative 2. Make a line like that. Okay, let's change the color. That's I2. Now I want to find I1 and I2. So how I'll do it? I'm going to add them. I will say the total current I of t, is equal I1 plus I2. But because I2 is DC, I just make it uppercase. What's I1? We found I1. It's 1 sine 10t. I don't have to write 1. Sine 10t minus 45 degree plus I2, which is equal to minus 2n. So that will be the total current. Of course, as you see, it has two components, AC and DC. You want to sketch it? Simple. Let me just sketch it here. If you have, that's the time axis, and you got this. The first one was a sine wave, and it was like 40 degree. Let me just, I'll put the x-axis in the end, because I'd like to make the sine wave nice one. So I'll say this is sine wave, right, that's one, and then the other one, I'm just sketching the first component without the DC, I1. The red one is I1. And we say that that's 45 degrees, so I'll make the axis in the middle. Yeah, so that's not a nice vertical. Oh, okay, that's nice. And if you make the other side, should be like that. So and that's the 45 degree starting. So that's right. 1 and negative 1. That's I1. I2 is equal negative 2. It's a DC. So that's 1, 2, that's negative 2. So I will have it like that. And that's I2. Now I want to add them. All right, so let's add them. So when you add them, everything will be added like this is 0, 0, and negative 2 will be negative 2. This point will move here. The maximum 1 and negative 2 will be negative 1. That will be the max. That will be the 0. Negative 1 and negative 2 will be negative 3, because that's negative 3, right? And this negative 1 is 0. So actually the whole thing will be shifted. So I'm going to just do it like that. And so that will be the one in black here will be I total. So you'll see that the minimum value is negative 3, the maximum value is 3. And that's the solution graphically, I'll show, and this is the solution analytically, expressed as an equation. So you see now the value of superposition. That's the second time you see superposition. I will just give you a simple assignment. This circuit that will start, I'm going just to give you something simple here. The same circuit, we have it. I'm going to have E2 different this time. I'm not going to make it DC. I'm going to make it another one, EC. All right, and E2 will be equal 15 root 2 sine 20 t. Okay, so what does it mean? It means if you want to have the phasor will be equal 15 on angle 0, but omega 2 is equal to 20, and apply the same thing. That's it. So just try to solve it, and then we'll check the result, and that was the answer. I hope that you got it. All right. Thank you.